Hi there. We're going to take a look at something called continuously compounded interest. The formula for continuously compounded interest is A is equal to P times e to the RT. A stands for the account balance, E is a number that we're going to talk about, and R is the interest rate, and T is the time in years. Earlier, we talked about the compound interest formula. Well, I want you to look at something. In the compound interest formula, N is the number of times that interest is compounded annually. For our purposes right now, I want to show you where E came from, the continuously compounded interest formula. If you just look at the part of the compound interest formula that contains the N's, I want to just do a few problems with you. I'm going to change R to 1 because we don't really care about the interest rate right now. I just want to look and see what happens when N changes, okay? So let's say that let's say that your interest was compounded 4 times a year or quarterly. We're going to use my calculator in a second to figure out what that approximately equals. And then we're going to look at when your interest was compounded monthly, okay? By changing the number of times that you compound interest, you're getting closer to continuously compounding interest. Okay, so if you compound interest quarterly, you get 2.4414 when you plug those numbers into the calculator. If you compound it monthly, you get 2.6130. I also plugged in 100 for N and then 10,000 for N. On the next screen, you're going to see the calculations on the calculator. Okay? Well, for our discussion purposes, I also put E into my calculator. E to the first is the same thing as E, and that turns out to be 2.71828, and so forth. Okay? So, as you can see, these numbers, the more often you compound your interest, they get closer and closer to E. And so basically, I just want to, without going too far into this, when you compound interest a certain number of times per year, this was what we used. But when you compound interest continuously, the formula changes to that, because the more and more you compound interest, the expression inside the parentheses of the compound interest formula gets closer and closer to E. So with that said, you don't really need to know where it came from. I just don't like having formulas where I don't understand where a certain number came from in the formula. Okay, so let's take a look at this problem. Okay, this says your great-great-grandfather borrowed 30 cents 100 years ago from someone who compounded the interest continuously. You now have to pay it back because he forgot. How much do you owe? The interest rate was compounded at 5% continuously. Okay, so let's write down what we know. We know that the principal is 30 cents. We're going to use E because it's compounded continuously. We know that our interest rate is 5%, which written as a decimal is 0.05, and we know that time is 100 years. So we simply plug these values into the formula to calculate our account balance after 100 years. Alright, so I'm going to take a minute and put that in my calculator. So when I typed that into my calculator, I did 0.30 E raised to the 0.05 times 100, and I got 44.523. So my account balance is $44.52. That's what I need to pay back the lender after 100 years of continuously compounding interest.